Hello students, let's try to understand conductance of electrolytic solution. Okay, so electrolytic solution is what, student? That is the salt solution, you can say, or the acid solution or the base solution. They are all called what? Electrolyte. So anything which are furnishing the ion, student, giving the ion, that is called electrolyte. Now student, how can you be able to understand? It is necessary to define a few terms before we consider the subjects of the conductance of the electricity through a electrolyte solution, right? The electrical resistance is represented by the symbol R and its measure in the ohm, which is term SI. Base unit is equal to the kg meter square per second cube ampere square. It can be measured with the help of the Wheatstone bridge. So resistance is always measured with the help of Wheatstone bridge, with which you are familiar from your study of physics. The electrical resistance of any object is directly proportional to its length and inversely proportional to the area of the cross sections. So this is the two equation. So directly proportional to length and inversely proportional to area of cross section. If you are removing the proportionality constant, so R is equal to rho L by A is coming. Okay, rho is, now let us see. The constant of proportionality, rho, Greek word rho, is called resistivity or also is specific resistance. Its SI unit is ohm meter and quite often its submultiple ohm centimeter is also used in IUPAC. Recommends the use of the terms resistivity over the specific resistance. So you are going to use the term resistivity, and hence the rest of the book we shall use the term resistivity. Physically, the resistivity for a substance is its resistance when it is 1 meter long and its area of the cross section is also 1 meter square. It can be seen that 1 ohm is equal to 100 centimeter, 100 ohm centimeter, 1 ohm centimeter is equal to 0.01 ohm meter. The inverse of resistance R is called the conductance, capital G. Conductance is capital G, and we have the relation. So inverse of resistance, this is this one. If you are placing the value of rod R, so A rho L. Okay, now after that it is going to be what, student? AL is rho, 1 by rho is equal to, it is going to be constant, so KAL, right? The SI unit of conductance is Simon, represented by the symbol S, and it's equal to the ohm meters inverse, also known as Maho. The inverse of resistivity is called conductivity. Inverse of resistivity, this is what the K is, conductivity. Specific conductance is represented by symbol K, Greek, that is called kappa. IUPAC has recommended the use of the terms conductivity over the specific conductance, and hence we shall use the term conductivity in the rest of the book. The SI unit of conductivity are the Simon meter inverse, but quite often K is expressed in the Simon centimeter inverse. Conductivity of a material is Simon meter inverse. Is its conductance when it is 1 meter long and its area of the cross section is 1 meter square. It may be noted that 1 Simon centimeter inverse equal to 100 Simon meter inverse. So here the conductivity, concentration of material, and conductivity. Here Simon meter inverse, student, these are there. This is also material. So sodium, it is there 2.1 into 10 power 3. Copper little more is 5.9 into 10 power 3. Silver 6.2 into 10 power 3. So silver is quite high, student. Okay. If you see other one, you will not find more than the silver. Silver is having highest conductivity. After that copper is there. Then gold is there. Sodium also there. Okay. So these are the, now It can be seen from the table 3.2 that magnitude of the conductivity varies greatly deal with the depends on the nature of the material. It also depends on the temperature, pressure at which the measurements are made. Material are classified into conductor, insulator and the semiconductors depending on the magnitude of their conductivity. Metals and their alloy have very large conductivity and are known as conductor. Certain non-metal like carbon black, graphite and some organic polymers are also electrically conducting. The substance like glass, ceramics, etc. having very low conductivity are known as insulators. Substance like silicon, doped silicon and gallium arsenide having conductivity between the conductors and insulators are called semiconductor and are important electronic material. Certain materials are called superconductor by the definition, have zero resistivity or infinite conductivity. Earlier, only metals and their alloys at very low temperature 0 to 15 Kelvin were known to behave as superconductor. But nowadays, a number of ceramic material and mixed oxides are also known to slow superconductivity at temperature at high 150 Kelvin. Electrical conductance. Though metals is called the metallic or electronic conductors and is due to the movement of the electron. The electronic conductance depends on the nature and structure of the metal, the number of the valence electron per atom, temperature it decreases with increase in temperature.